I'd like to dedicate this video to Sao Khan from the Khan Academy. In this video, I'd like to give you an intuition as to why when we perform an arithmetic average operation, that the divisor n is the number of data elements in question, that's the best number we should pick, that it shouldn't be any other number. So let's begin with the definition of the arithmetic average. Recall that it's x1 plus x2 plus xn divided by n. So a better way of thinking about this is to rewrite this where the n that's being applied to each data element is made more explicit. So we can rewrite it as 1 divided by n times x1 plus 1 divided by n times x2 plus 1 divided by n times xn. So what does this give us? Well, it gives us a different way of looking at the operation. This is saying that for each data element, I want you to take a slice of the data element, and then I want you to combine them at the end. And this composite number should best represent the underlying data population. Let's walk through a visual example to make this a little bit more explicit. So let's say that you have 3 slabs of butter. So you have one slab right here, and let's say that the area of this guy is 2 inches squared. And you have another slab right here, and let's say the area of this guy is 2.2. And you have one slab right here, and let's say the area of this guy is 2.4. When we say that we want to take an average of these slabs, we're saying that we want to have some kind of abstract slab that best represents the underlying population. So if you were to take a slice from each one of these slabs, the question I would ask you is, how big of a slice would you take from each one of these slabs to create the composite slab? Let's say that you take a half from each one of these slabs. So then what would that look like? What would that number look like? So that's a half times 2 plus 1 half times 2.2 plus 1 half times 2.4. And I already worked this out ahead of time. That's going to be 3.3. Oops, 3.3. Now, would it make sense that 3 is the number that we should use to represent the underlying population? Well, no, because 3.3 is bigger than any one of these numbers. It doesn't even resemble closely to any one of these numbers. So I would say that that's not the best representation of the underlying population. So let's say instead of using 2 as the divisor, let's say that we use 4 as the divisor. So let's say we use 1/4 times 2 plus 1/4 times 2.2 plus 1/4 times 2.4. And I worked this out ahead of time as well, and that's going to be 1.65. And does this make sense that we should use this number to represent the underlying population? I would say no as well, because this is too small. This is too, so when we use a divisor of 2, the number is too big. When we use a divisor of 4, the number is too small. How about if we use 3 as the divisor? So if you use 1/3 times 2 plus 1/3 times 2.2 plus 1/3 times 2.4, I already worked this out ahead of time, that's going to be 2.2. That seems about right. That this would make sense that we would use 2.2, that 2.2 should represent these data elements right here. And in fact, it is right. The other argument that we can lean on is the fact that the arithmetic average is a measure of central tendency. So if we look at these data elements, well, what's the central tendency of these data points? Well, without even doing any math, we would say that it's 2.2. This guy is equidistant to this guy right here. It's about 0.2 inches squared bigger than this guy. This guy is 0.2 inches squared smaller than this guy. So these are two ways that we can use to reason about why the divisor is n, why it is the number of elements. We can use the visual argument, and we can also appeal to the central tendency argument.